Number 32, longest valid parenthesis. Given a string containing just characters left and right parenthesis, find the length of longest valid parenthesis substring. We've tackled similar questions, which is to check if the string of parentheses are valid or not, right? We use the stack. If we meet if the left parenthesis is met, then we push it into the stack. If the right is met, we pop the stack and match it and go to the next one and do it recursively. And at last, we check if there is any elements in the stack. If there's none, then the string must be valid. Okay. So now in these questions, we need to find the longest valid substring. Like this, yeah, of course, the valid one is like this. So the longest is this. For these, the longest, well, is this. So the longest is like this. So how can we do it? Because we've done the similar questions by using a stack, we keep using the stack to do things like this, right? Okay, let's take this as an example. We use a stack. Okay. Now, when we met this, because we check the stack. There is none there, and yeah, we can ignore that. And then we push this into the stack, and now we get the right one, and then we pop it and the match. So these must be valid, and then push next one, and then pop it again. This must be valid too, but these four must be these four are connected. So this in total must be a longest string. How can we do that? Yeah, yeah. Yeah. Maybe we just yeah, we just if we cannot meet the parenthesis, we just push it in. Like if we want to get the length of this part, we just find the index of this and the index of this and just subtract them. By subtraction, we can find the length of these four parentheses, right? If that's the case, we need to find the index of the parenthesis. So if that's, we just okay, we push it into the stack like this first, and then we find this, and we got it, and we pop it, and then fuck it again, we pop it, and we find this, then the longest string. When we find something that is not met, we find this substring, right? Now I finally notice something. It's like, say, our substring is something like some invalid parenthesis like x, and some valid substring, right? Something like this, XOXXO. It's like this. We just need to find the longest O, like this, right? If we need to find this, we can just pop them up and leave the X in the stack and calculate them. Right? Hmm. Yeah, at last it must be something uh, the invalid one must be like this, because these couldn't be matched, right? With this must be something like this. There couldn't be something some right parenthesis at the right part. It must be like this. Then we can just push them into the stack and finally do the calculations. Yeah, if we put this into the stack, how can we get the index of the particular parenthesis? We cannot do that, but we can actually get the parenthesis from the index. So that reminds us that we can actually use a stack to keep this index, right? Okay, for like okay, first one we get this, we got 0, and then because this is not this, the first one push it, and then this one, okay, push it, and then this, we pop it, and then we got this one, 3, and we pop it, and then we got this is 0, 1, 2, 3, 4, 5, 5. And that's not pushing in 5, but we get it, and we check that the last invalid one, which is this x, and we find this x, the last invalid one is 5, in 0, so 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 5. So there are 0, 1, 2, 3, 5. Yeah, there are 4 there, so we can update the maximum and push 5 in it, and then check the next one. Could you pop it and update it to 5? Yeah, can use the stack to keep only the rightmost invalid one. Okay, so our solution is use a stack to track the invalid parenthesis index. Parenthesis. This is parenthesis. Anyway, so we use a stack. Okay. For okay, so if the irregular case, if s then is 0, return empty. For I equals 0, smaller than s dot then I plus plus. If I is if we don't use this command. If I equals left, we stack push I, right? In the other case, we made a right one and check if top is matched. Const top equals stack pop index. Okay, if there is none. If there is none element in the stack, then we should it is from the beginning. Okay, so here top index would be stack pop, or because it might be undefined, so stack.length if it's bigger than 0, then pop. If not, -1. Constant it should be not by 0, but this index is from must be from 0. No, it's -1. We'll just use another if. Okay, if stack.length is 0, then wait a minute. So we need to check if there is nothing there and it's right. We just check if there's no element in the stack. It's from beginning. Yeah. So we also check let result equals if I is bigger than result length. If it's 0, then this should be 1. Length is 1, so I plus 1. If it is longer, the length should be is I. Plus 1, minus 1. 1, 2, 3. Length should be 2. Get the length of strings to the left side. Okay, so if this is true, result equals as a slice 0 I. If this is true, then we should push it, right? If it is small, anyway, if it's smaller, it's okay. So we just push it. Stack push I. Okay. If it is not, then because the top equals stack top index. We pop it. If it are not matched, then check the substring. If they are not matched, it might be something like this and this, right? So the things between them might be a possible case. So if I like top index is 1, current is 1, 2, 3, so minus and minus 1. So I minus top index minus 1. If it's bigger than the result, then it should be slice top index plus 1 I. and we need to, oh no, it might be like here, the one might be a left string, left parenthesis. So okay, if s index equals left, then we just pop it and do nothing. So only we check it if it's not left, and if they're right, if it's bigger, then we update it. We can just pop it. If the is there any cases that all the right parentheses are pushed in? When we meet the second right parenthesis, we already popped the first one, and then we will push the right one. So stack push I. We still push I. Okay, and then finally we can return result, right? No. If when we are done, and it's just with the valid string, it's like this. It will be only thing. It won't be invalid x left in the stack. So we need to check the strings up here, right? And finally, we need to check if I is the s plus 1, length plus 1. So if s length here. So if I minus, we'll check it again. If that's the case, maybe because it's undefined, so we can actually safely check it to s length, because it's not left one. If it's not left one, so it's invalid, and we will check here. If it's valid, we check it here. Yeah. This should work. Let's just try it. It's not. Topping the stack pop is not a function. Stack it slicks. Stack. Stack is not a function. Pop. It's not top. Let's take a look at the time complexity. For the time, okay, we have a wrong answer. But for this case, we actually traverse all the elements just once, and do it in a constant if checks, and had a stack, which maximum has the on, so time is on. Space is on. Output is 0. Expected 2. A length. Okay. We only check the length. Result. It should be 0. And if this result equals, if that's the case, we max result. This result. This. Zero. Weird. Okay. I stack length -1. So the first one is we push into it. Because this, we just push it. Second one, this, we push it. Third one is this. Stack length is not 0. Top is this, because it is left, do nothing, and then we finally go to S, the next one. I3 undefined, and top index is 0. The okay, here is or top, or but this means not valid, right? Or I is bigger than s.length. Then means this means that it is not, it is still invalid. You run the code. It seems that it's accepted. Let's run submit. Run answer. It's weird. Let's copy the test case here and console log stack. Okay. Okay, that's 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5, 6. And we go to down 5, 8, then go to 5 again, go to 4, 2, 0, 1, 2, 0, 1. Got 24. I see. We made a case that this is also still invalid, so if they're not pairing, they're not valid. So if this, we push it, but we still need to check. We still need to check the possible string there. Right, so top, we need to check this, right? There's no if check. It will definitely not be valid here. So result equals max I minus top index -1. Top index, yeah, top index is stack stack length -1. accepted. Remove the console. We made a mistake that actually we need to. These are also not valid. Not a number. Stack. Okay, so if there is one there, one and two, there'll be zero. Okay, if one and minus one, it would be one. So 1, 0, minus 1. If there is no stack there, okay. Accepted and faster than 72%. Here we need to pay attention about consequential left parenthesis, and the case of the starting point, which is kind of error prone. Yeah, we need to take more consideration there, and we are able to derive the solution from the past problem we have done, which is the valid parenthesis. So we need to remember as more cases as we can so that we can solve more problems. That's all for this time. See you next time. Bye bye.